Hello everyone, my name is Zhishan Huang. I'm come from Taiwan Chaoyang University of Technology. My topic is the influence of the angle of feature point for indoor positioning by machine vision. This is my outline. Introduction. In the previous work, 3D scanner is used to obtain environmental features, and image processing technology is applied to achieve positioning function, but did not further analyze the accuracy of this method. In this paper, we will experiment with the proposed indoor positioning technology to understand the influence of its positioning. Indoor positioning method. Our camera is placed indoors and overlooks from top to bottom. There are 4 feature points: F1, F2, F3, and F4 on the 4 walls. Every 2 of these 4 feature points can form a circle with C. The angle between the sum of these 2 angles is the angle between the F1 direction and the F2 direction. When the location of F1 and F2 with the angle are known, the location of the camera can be R1, R2, R3, or any point on the circumference. A circular expression can obtained by every 2 feature points captured by the camera. The possible position of the camera is on this circumference. We can get an intersection every 2 circles. In our example, we can get 4 intersections as denoted with C1, C2, C3, and C4 in Fig 2. The average of these 4 positions is the camera position, which is the positioning result. Simulation space, experiment, and result. We made a space of 90 cm times 60 cm times 30 cm, the simulation space. 4 colors on the 4 sides of this space are used as feature points. The camera we used is Reseta S, which is a camera that can take panoramic views. We place the camera in 2 locations in the simulation space are point 1 and B. Each position of the camera shot image in 2 directions, and the image of 4 directions A1, A2, B1, and B2 can be obtained. We can easily find out 4 feature points for the 4 image by color features. The angle is estimated by the 4 images to each feature point are shown in Table 1. We can see that when there is an angle is large, the error will be increased. Real space, experiment, and result. This space is room M218 of Chaoyang University of Technology, with a space of 7.8 meter times 6.8 meter. 7.1 meter times 6.8 meter. The location of the circle of the 4 circles. The location of the 4 colors paper are known. We randomly take 2 locations of the camera is this space as shown with point 1 and point 2. We shot 9 images in each position. We will adjust the camera's shooting angles in each times we shoot an image. Each image is calculated by proposed method to apply to obtain the angle of each feature and the positioning error. From figure 6, we can see that there are 2 arrows greater than 20 cm, where arrow feature point has an angle greater than 72 degrees, and another feature point angle greater than 52 degrees. In 3, one angle is greater than 72 degrees, but the other 3 angles are less than 40 degrees. In 8, there are 2 angles greater than 72 degrees, but the other 2 angles are less than 30 degrees. From figure 7, only the error of 4 is greater than 20 cm, where there are 2 feature points have an angle greater than 73 degrees, and even one of them over 80 degrees. Conclusion. According to the experimental result of simulation space and the real space, we know that the angle between the feature direction and the camera shooting direction will affect the accuracy of the positioning. The image taken by the fisheye camera will be distorted and reduce the resolution, especially when the object is at the edge of the image. In a case that there are enough feature points, the feature point with a large angle can be discarded to improve the accuracy. At the same time, if we can understand the distortion feature of the fisheye lens, we can also improve the positioning accuracy. Thank you for listening.